of the trapezoid with height 20 meters and width 50 meters at top and 30 meters at bottom. Our goal is to find the force on the dam due to hydrostatic pressure if the water level is 4 meters from the top of the dam. Okay, so in order to calculate force, well, we know something from this equation that says force is mass times gravity. Okay, but now since we're considering for a force in which the mass is due to water, so here's the water level, and by the way, that Greek letter rho represents the density of a fluid. So for water, that's 1,000 kilograms per cubic meter. And so you might ask, well, what is this mass I'm talking about? You know, exactly how does this formula work? Well, I'm going to make that 0, okay? So, I mean, remember there's a height from top to bottom of 20 here. So I'm going to call this -4. And I'm going to go down a distance. This is going to be the x-axis, okay? I'm going to go down a distance x sub I. Okay, so this distance is x sub I. And so I can make a little strip right here. And this is going to have a width of delta x. So that's going to have a width delta x. And so the reason why this has weight is because the weight of the water above it has a density, and that's being weighed down. That's 1,000 kilograms per cubic meter. But how much water is above it, or weight is above it, is a function of the area that this little strip occupies times by the amount of water above it, the distance, d, or in this case, x sub I. And so for us, we're going to have this mass as rho, which is 1,000 in this case, times by area, A sub I. So I'm going to call that A sub I. This is the area of A sub I. And we're going to multiply that by a distance, which in this case is x sub I. Okay. So this little equation right here, that is our mass. Now, if I plug this equation in and I want to find the total force that is being exerted here, it's the sum of these forces. If I were to make a bunch of little strips of width delta x, I would just add the forces. Well, what happens if I inscribe infinitely many subrectangles and I divide up this interval infinitely many times? Well, that would give me the exact force. So I have this limit as n goes to infinity of adding up the forces of f sub I. This equation becomes 1,000 times by gravity, which is 9.8, multiplied by area, a sub I, and multiplied by the distance that's above it, x sub I. Okay. Okay. So let's try and determine the area, because that's like the last thing that's left for us to do here. So if I want to determine this area, A sub I, well then I need to remember what I'm looking at here is a little strip. And this little strip looks something like this, right? So it's going to have length delta x is going to have a length L sub I. And so I'm going to say that this area is going to be L sub I times by delta x. Now, you should notice that the length of this little strip as it moves up and down the dam, right? The length at the very bottom is only going to be 30 meters wide. And if it could go to the very top, it's not filled to the top, it's filled to a height of 16 meters. That at the very top, if it could go to the very top, would have a length of 50 meters. So this length is changing with the height x sub I. Okay, so ultimately I need to know, like, what is L sub I, right? Well, let's look at this equation just a little bit more. And I'm going to recreate this. So let's go with this recreation. Okay. And remember that I have this length here, L, and it's somewhere here. Okay. So this whole thing is L. And also remember that this from here to here, that's 30. Okay. Okay. So I think L is going to have is going to have 30 right here, right? Then I'm going to put in another variable, and that variable is going to be this width, A. So I think this length is going to have twice A, okay, 30 plus twice A. Now, the only thing we have to figure out is A. Now remember, the width at the bottom is 30. The height at the top here, from here to here, that's 50. So like 50 minus 30, that's 20, but then I have to distribute that evenly to both sides. Remember, this picture should be symmetric. So there's going to be 10 and there's going to be 10 here. Okay. And so let's focus in on just a little portion of this. So we can see that there's a triangle. Let's look at this triangle. So if I explore this triangle, I know a couple of measurements. I know there's 10 at the top, and I know the height from here to here, that's 20. So there's 20. I'm going to call this little piece here, that's A. Now remember, there was a water level, and we went down from here to here, that's x sub I. And there's 0 right there. Okay. Now, the total distance, this was a -4, and this went all the way down. That's 16 units from top to bottom. Okay, so some of these measurements get a little bit mixed up. I have an x sub I, and here is x sub I right here. But excuse me, one thing I need to do is that this x sub I is from here to here, right? This is going to be x sub I. That's going to be 4 from here to here. Okay. So we have to notice like a couple of things. So let me redraw this triangle. There are two similar triangles. Okay. One of them should not be a surprise. It's just this black triangle. It has 10 at the top. It has 20 right there. Okay. Here's going to be the other triangle. And I think it'd be convenient just to draw this other triangle in red. Okay, so there's that other triangle. It has a width of A, other than this long length. Well, the total length is 20, but I need to subtract x sub I and I need to subtract 4. So this is going to be 20 minus x sub I minus 4. That's that length. And that's going to be 16 minus x sub I. So because these are similar triangles, I'm going to get this relationship. Means that the ratios 10 over 20 has to be equal to A over 16 minus x sub I. Our goal is to eliminate the unknown A. So we can solve for A. This is going to be excuse me, A is equal to 16 minus x sub I divided by 2. That's our equation for A. So now I can take that and I can plug it in for the length. It's going to be 30 plus twice times 16 minus x sub I over 2. So L, the length of the little strip, is going to be 30 plus 16 minus x sub I, or 46 minus x sub I. Okay, now we have our equation for L. Okay, and now we can determine the area. The area here is going to be equal to this. Is going to be equal to 46 minus x sub I multiplied by delta x. Okay, and now we can go ahead and plug this into the equation for force. So we're going to take this equation for force right here, and we're going to go ahead and re-express it. So force is going to be equal to this limit as n goes to infinity of the summation from I equals 1 to n. So infinite subdivisions of this 1,000 multiplied by 9.8 from gravity multiplied by, let's just check, So area is going to be our 46 minus x sub I multiplied by delta x. Okay. And remember, I also have this x sub I in blue right there. So I need to multiply by x sub I. And now I need to get rid of that little arrow because it's getting in the way. So multiply by x sub I. Okay. And now, as I take this limit as n goes to infinity, this becomes dx, this becomes an integral, and I just need to decide, this is the integral from a to b. Well, from where to where did I divide up? I divided up my interval here. Here's 0, and here's going to be 16. So from 0 to 16 is going to be my integral of this 1,000. So remember, this is the definition of integral. 1,000 multiplied by 9.8 multiplied by x, the i's drop, and I get 46 minus x multiplied by dx. That's what the delta x becomes. Okay. Now, we'll integrate this. This will be 1,000 times 9.8 multiplied by 46x. So 46x squared over 2 minus x cubed over 3. Okay, and then we evaluate at 0 and 16. Now the number that we get is going to be pretty large. So it's going to be 4.43 times 10 to the 7th, and the units become newtons. Okay, so anyway, this is how you work out your hydrostatic pressure calculations. And really the key thing to determine is this. Okay, what is your area? What's your equation for area? Identify your axes so that you can mark your distance d in terms of x. Okay, so your keys are to determine your little strip of area, which is a rectangle inscribed in the shape, multiplied by your distance here. Now, your distance could be in terms of x or it could be in terms of y. It depends on the situation. But your end goal is, once you determine area and distance, you're going to have a limit. And this limit comes from this definition. It's the sum of the forces as you take infinitely many subdivisions. So anyway, once you do that, you'll be able to calculate it. You'll get an integral that looks like this. Now, not everything is going to be a similar triangle. There'll be different scenarios that arise in each situation. Okay, but your general form is to use this. Okay, this is what your force is calculated as, and to take it from there. Okay, so I'm going to stop here. We've solved this example, and you'll see some more examples in your homework. Thank you.